Okay, so in this video here, we're going to be talking about factoring quadratics, and in particular when a is not equal to 1. Now, I have already done a video on factoring when a is equal to 1, so you're going to want to go ahead and check out that video before trying this one here. I'll go ahead and link it in the description box below, that way you have access to that content. So please try that video before trying this one here, but I'm going to assume you know how to factor already when a is equal to 1. So let's get right into this video. Now, a couple of key points we have to go over. We have to know what a quadratic is in standard form, and that is going to be ax squared plus bx plus c. We need to know that because we factor using the AC method. That's the way that I teach. I find it to be the most mechanical and easy way to factor. Okay, so you have to know how to write a quadratic in standard form, and again, you should know that if you are factoring, and that is going to be ax squared plus bx plus c. Okay. Now, as you're factoring, you're going to want to follow these 3 steps here. And you can see they're on my screen now, and it says steps to follow. Step 1, put the quadratic in standard form by setting equal to 0. So if your quadratic is not set equal to 0, you want to make sure that you go ahead and do that. And by doing that, by default, you're going to be putting it in standard form. Now, step 2, see if you can pull out a greatest common factor between your terms. So you always want to see if you can pull out a greatest common factor once you have that quadratic in standard form. It could make the problem easier for you, and it could make less work for you. So you always want to try to pull out a greatest common factor between all of your terms, okay? And then step 3, factor using the AC method, which we're going to do in this video here. So let's take a look at our first example. So here's our first example, and just going through the steps, is it equal to 0? And it is. Now, they didn't write equal to 0, but technically this whole quadratic is going to be equal to 0, okay? So from here, we go to step 2, can I pull out a greatest common factor? In other words, do all of these terms here have something in common that I can pull out? And unfortunately, they do not. So that's okay, we're gonna go right into the AC method. So let's go ahead and get rid of this here. So I have to do a times c. So a times c for me, again, quadratic in standard form. This is my a, this is my b, this is my c, okay? And so a times c, that is going to be 9 times 14. So I'm going to do 9 times 14. When I do that, I get 126. So from here, you have to come up with 2 numbers that when you multiply will give you 126, but add up to your b coefficient, which is 27. Okay, so this may take a little bit of work, but use your calculator, start dividing 126 by various numbers, and you should eventually get those 2 numbers. So in my calculator, I just did 126 divided by 6. I happened to get lucky here. And when I did that, I got 21. So 6 and 21, if I multiply them, I'm going to get 126. That checks out. If I add them, do I get 27? And I do. So we're good. We don't have to do anything else here. Now, if a was equal to 1, you could put this right in factored form. So for example, you could do in parentheses x plus 6, and then x plus 21, and that would be done. Unfortunately though, a is not equal to 1 here. So when a is not equal to 1, you have to do something called factor by grouping, okay? So let's get rid of this here. And so what you're going to do is you're going to rewrite the quadratic. So I'm going to rewrite the quadratic. It's going to be 9x squared, just going left to right. And when I get to this 27x, or in other words, my bx, I'm going to essentially break it apart by using the 2 values that I came up with. So in other words, I'm going to write plus 6x and then plus 21x, okay? So you can see that when I add them, I do get 27x. So I'm not actually changing anything, I'm just breaking them apart, okay? And then I write plus 14. Now, let's be clear here. You could have written the 21x right here, and you could have written the 6x right here. It doesn't matter the order that you're writing them. As long as you're writing them in place for the bx, it doesn't matter the order. You'll end up getting the same answer in the end, okay? So from here, you should have 4 terms, and I do. I have 1, 2, 3, and 4, okay? So when you factor by grouping, you need to have 4 terms. We do. So from here, we group together the first 2 terms, and then we group together the last 2 terms. And then we pull out a greatest common factor. So what can I pull out between my first 2 terms here? Well, I can pull out a 3, and I can also pull out an x. That leaves me with 3x plus 2. Okay, close it. What can I pull out between my last two terms? Well, it looks like I can pull out a 7 here. So plus 7, and then in parentheses, I'll have 3x plus 2. So what do you notice right now about the problem? Well, I have a common factor. This right here is called your common factor. So if you do factor by grouping correctly, you should have a common factor. That's like your confirmation that you did the problem correctly, okay? And this problem here, I see that I have a common factor, meaning I did it correctly, and I'm pretty much done. So all you have to do now is write the common factor one time, which is going to be 3x plus 2, okay? And then write your outside values together. So 3x plus 7. So in parentheses, I'm going to write 3x plus 7. And this problem is now completely factored, all right? So when a is not equal to 1, you have to go one step further and you have to do factor by grouping, all right? Let's try a few more examples. So here's our next example. Go through your steps. Is it equal to 0? And it is not. So we're going to rewrite it. We get 8x squared minus 6x, and we're going to move this 27 over, so minus 27, all equal to 0, right? Step 2, can you pull out a greatest common factor? This problem here, we cannot, not a big deal. We're just going to go ahead and use the AC method. So a times c. What do I get there? I get 8 times a negative 27, right? That ends up giving me negative 216, okay? So again, I need two numbers when I multiply. That will give me negative 216, but add up to my negative 6 right here, right? Add up to my b. So using your calculator, you can come up with those numbers, but you should end up getting 18 and 12. Now, one of them is going to have to be negative. So for example, I'm going to write 18 and 12. When I multiply them, I get positive 216. I need a negative 216. So if I make this 18 negative, when I multiply them, I get the negative 216. When I add them, I do get the negative 6, right? That will check out. So we're good there. Now I have to do factor by grouping because a is not equal to 1. So I'm going to rewrite it. I get 8x squared. And remember, you can grab either one. I could grab this one or this one. It doesn't matter. I'll just grab the 12. I'll put plus 12x here. And then minus 18x. And then minus 27, all equal to 0. So from here, we want to factor by grouping. So I'm going to group together my first two terms and then my last two terms. What can we pull out here? Well, it looks like I can pull out a 4. I can also pull out an x. So 4x. Then I'll have 2x and then plus 3. Okay, close it, done. This one here, what can we pull out? Well, I can pull out a negative and I can also pull out a 9. So I'm going to pull out a negative 9. That leaves me with 2x plus 3. So again, our confirmation is right here. We have a common factor, 2x plus 3. We did it correct. So now we can rewrite the problem. Write the common factor one time, 2x plus 3. And then the outside values together, which are going to be 4x minus 9. So 4x minus 9. Okay, done. So that's completely factored. All right, let's try some more problems. So here's our next problem. Again, is it equal to 0? It is equal to 0. Can you pull out a greatest common factor? And in this one here, I can. I can actually pull out a 3. And when I do that, I'm going to get 3. And then in parentheses, I get x squared plus 2x minus 63. This is all equal to 0. Okay? So what you want to look at is this part here. Don't worry about that 3 that you pulled out. We're just going to be looking at the quadratic. This 3 right here is going to come along for the ride. So you're going to include that in your final answer. If you look at the quadratic, a is equal to 1. This one's going to be super easy. So all we have to do here is do the AC method on this part here, factor it, and then we're pretty much done. So a times c, that will give me 1 times negative 63, which is negative 63. So I need two numbers when I multiply. That will give me negative 63, but add up to 2. So let's start with 9 and 7. When I multiply 9 and 7, I get positive 63. All right, let's make one of them negative. So 9 times a negative 7 will give me negative 63, and 9 plus a negative 7 will give me the positive 2. That checks out. And a is equal to 1, so I can put it right in factored form. So putting it right in factored form, I have x plus 9, okay, x minus 7, and then don't forget about this 3 that's going to come along for the ride. I just put that 3 right at the beginning, just like that. And you can actually put it in parentheses if you want, that's fine. And that's done. That's completely factored. Okay, so that's why you always want to try to pull out a greatest common factor, because it could make the problem easier. There could be less work for you. Now, if you did not pull out a greatest common factor, you're not going to get it wrong. You're just going to have to go through the process of factor by grouping, and it's going to be more work. But you will get the same answer in the end. Okay, so again, just always try to pull out a greatest common factor if you can. All right, let's do 2 more problems. Okay, so this one here is equal to 0, even though they did not write it, but we can put it right here, equal to 0. Can you pull out a greatest common factor here? And on this one, you cannot. Again, you can use your calculator to check, but you cannot pull out a greatest common factor here. What I could do to possibly make it a little bit easier, I could pull out a -1. That way my A value here is not negative. So I'm going to go ahead and do that. Now, you don't have to, but I'm going to, just to try to make the problem a little more manageable. I'm going to pull out a -1, and by doing that, all my signs will change here. So now I have positive 9x squared minus 54x, and then plus 80, okay? So again, just like the other problem, that factor that we pulled out is just going to come along for the ride. So this -1, we're just going to include it in our final answer at the end. I'm really going to be looking at this part right here. That's what I want to factor, okay? So A times C, A times C, I get 9 times 80, okay? When you do that, you should get 720. So now I need 2 numbers when I multiply that will give me 720, but add up to -54. And again, this is not very obvious. You're going to need a calculator. But when you're using your calculator and you start dividing out numbers, so again, start with 720 and start dividing out numbers, you should come up with 24 and 30. So I'm going to write 24 and 30. When I multiply them, I do get 720. When I add them, I get positive 54, not negative 54. So to get around that, I'm going to make them both negative, because if I make them both negative and I multiply, the result will be positive. So I'm still going to get that positive 720, but when I add them now, I get the negative 54. So that checks out, and now we're going to factor by grouping. So we're going to rewrite the quadratic, 9x squared. Again, grab any one of these values, it doesn't matter. I'll just grab the -24. So -24x, and then -30x, and then plus 80. Okay, all equal to 0, factor by grouping, and we're almost done. So what can I pull out between the first 2 terms? Well, it looks like I can pull out a 3, so that's what I'm going to do. I can also pull out an x. In parentheses, I'll have 3x minus 8. Okay. On the next 2 terms, it looks like I can pull out a -10. So I'm going to go ahead and do that. And then I'll have 3x minus 8, all equal to 0. So again, did we do it correct? Well, we did, because our common factor is the same, 3x minus 8. So we're going to write our final answer, common factor, 3x minus 8. Again, you only write it 1 time. Then you write your outside values together, 3x minus 10. So I'm going to write 3x minus 10. Now, don't forget, the very beginning, we factored out this -1 up here. So we have to include that in our final answer. I'm just going to put it right at the beginning, -1. You could even just put a negative in the front if you wanted to, but I'll just put a -1 there, that's fine. Okay, let's try one more problem. Okay, so here's our last problem. Is it equal to 0? It is. Now, if you look at it, it's already looking a little strange because it's not a quadratic, okay? Not a big deal. Go to step 2. Can you pull out a greatest common factor? And the answer there is, yeah, you can. It's not going to be a number, but you can actually pull out a variable. They all have an x in common. So if I pull out an x, I'm now going to be left with 9x squared minus 73x plus 8. So you can see here, by pulling out that greatest common factor, I am now going to be left with a quadratic right here. And now I can go ahead and factor it. Again, this part right here is going to come along for the ride. Okay? So I'm going to do A times C. If I do that, that's going to be 9 times 8. I'm going to get 72. So I need two numbers when I multiply that are going to give me 72, but add up to negative 73. And luckily, this one's a little bit easier. We're going to use 72 and 1. Okay, 72 and 1. When I multiply them, I get positive 72. Now, when I add them, I get positive 73, not negative 73. So again, to get around that, we're just going to make them both negative. So now when I multiply them, I still get that positive 72. But when I add them now, I get the negative 73. Okay, so now we're going to go ahead and rewrite the quadratic, 9x squared. It does not matter what value you grab now. I'm just going to grab the negative 72. So negative 72x. And then I have minus 1x, or just minus x, and then plus 8. Okay, again, all equal to 0. Now we're going to group together our first two and our last two terms. What can I pull out between my first two terms? I can pull out a 9. I can also pull out an x. Okay, I'm going to be left with x minus 8. Now, looking at my last two terms, it doesn't look like you can pull out anything, but you always have to pull out something, even if it's a 1 or a negative 1. So in this case here, I'm going to pull out a negative 1. When I do that, I'm left with x minus 8, okay, all equal to 0. So that's my confirmation. Our common factor is the same, so I'm going to write x minus 8. Write the outside values together, 9x minus 1. 9x minus 1. And then don't forget, we pulled out an x at the beginning, so we have to include that in the final answer. I'm going to put that right in the front, put my x right here, and that's going to be completely factored. Okay? So that is how you factor quadratics when a is not equal to 1. So I hope that you found the video helpful, and I hope that you gained something from it. If it did help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel so you get more math videos in the future, and I'll see you in the next one.